Dear students, today's topic is the classification of magnetic materials. Depending upon the behavior of matter in the presence of a magnetic field, the magnetic materials can be divided into three categories. They are diamagnetic substance, paramagnetic substance, and ferromagnetic substance. And this classification is based on the magnetic dipole moment of the atoms. When an atom or a matter which is composed of an atom is placed in a magnetic field, in the atom there is a central nucleus and the electrons which are revolving around the nucleus, and the electrons which are revolving around the nucleus in a circular path, and this path is called orbit. And the orbiting of the electrons, it is equivalent to a current loop. Electron is a charged particle. A charged particle in motion will produces a magnetic field, or it is associated with a magnetic moment, or it is equivalent to a current loop. In the case of an electron, it revolves around the orbit and also it spins about its own axis. Both the orbiting and the spinning of the electrons gives rise to magnetic moment. When such an atom is placed in an external magnetic field, its magnetic moments are affected by the external magnetic field. Then depending on the nature of the magnetic dipole moment of the atoms of the material and also its interaction among the atoms, the material can be broadly classified into these three categories. Next, what are paramagnetic, diamagnetic and ferromagnetic materials? Diamagnetic substances. Diamagnetic substances are those which experience a feeble repulsive forces in a magnetic field. That is, when a diamagnetic substance is placed in a magnetic field, a weak magnetism is induced in it in a direction opposite to the magnetic field. Paramagnetic substance means the paramagnetic substances are those which experience a feeble attractive force in a magnetic field. That is, when a paramagnetic substance is placed in a magnetic field, a weak magnetism is induced in it in the direction of the field. And the ferromagnetic substances. The ferromagnetic substances are those which experience a strong attractive force in a magnetic field. That is, when placed in an external magnetic field, a strong magnetism is induced in it in the direction of the field. Therefore, in the case of ferromagnetic substance, there will be a greater concentration of lines of induction of this in the substance, and hence these ferromagnetic substances are used to make permanent magnets. And next is the properties of diamagnetic substances. When freely suspended in a magnetic field, the diamagnetic substances sets itself at a perpendicular to the direction of the magnetic field. In the figure, it is shown that without the application of a field, the materials they are oriented randomly. When a magnetic field is applied, they are oriented in a direction which is opposite to the applied field. In the case of diamagnetic substances, in a non-uniform magnetic field, the material move from a region of a strong field to a region of weaker field. And the third property is that the susceptibility. The susceptibility is a property which determines how easily a specimen can be magnetized. And this susceptibility is very small in the case of diamagnetic substance, that is, it is negative. And the susceptibility is independent of temperature. And the relative permeability. The permeability means the ability of a medium to permit the passage of magnetic lines of force. And the relative permeability is slightly less than 1 in the case of diamagnetic substances. And the examples of diamagnetic substances are antimony, bismuth, gold, copper, and lead. And next is the properties of paramagnetic substances. When freely suspended in a magnetic field, the paramagnetic substance aligns itself in the direction of the field. As in the figure, without the application of the field, the materials are randomly oriented, but when a field is applied, it orients or aligns in the direction of the field. And the second property is that in a non-uniform magnetic field, it moves from a weaker to a stronger region. And the third property is that the susceptibility is positive and small. And the fourth one is the susceptibility varies inversely as the absolute temperature. And the fifth property is that the relative permeability is slightly greater than 1. And the examples of paramagnetic substances are aluminum, chromium, platinum, manganese, copper sulfate, etc. Next is the properties of ferromagnetic substances. And when a ferromagnetic substance is freely suspended, it aligns itself in the direction of the applied magnetic field. In the figure, you can see the effect of magnetic field in a ferromagnetic material. The second property is that in a non-uniform magnetic field, it moves from a weaker to a stronger region of the magnetic field. And the third property is that the susceptibility is positive and very high. And the fourth one is the relative permeability is very high. The fifth one is that as the temperature increases, the value of susceptibility decreases. And above a certain temperature, the ferromagnetic becomes paramagnetic. And this temperature is known as Curie temperature. That is, in the case of ferromagnetic materials, as the temperature increases, the susceptibility decreases, and above a certain temperature, the ferromagnetic material becomes paramagnetic. And this temperature is known as Curie temperature. And examples of ferromagnetic substances are iron, cobalt, nickel, etc. Next is antiferromagnetism. In some substances, the electron spins are naturally oriented in antiparallel directions. As in the figure, we can see the spins are oriented antiparallel directions naturally. That is the nearest spins. The spins in the adjacent, you can see it gets cancels, and hence there is a zero net magnetization, and such a substance is called antiferromagnetics. That is, in the case of antiferromagnetic material, the electron spins are oriented in an antiparallel directions, so that the net magnetization will be zero. Such substances are called antiferromagnetic substances. Examples are iron oxide, manganese oxide, and nickel oxide. So antiferromagnetism means in some substances, the electron spins are naturally oriented in antiparallel directions, resulting in a zero net magnetization. Next is the ferrimagnetism. This ferrimagnetism is similar to the antiferromagnetism. Here also the spins are oriented in the opposite direction. But here the net magnetization is not zero. That is, in the case of ferrimagnetic materials, the magnetic moments in one direction are different from those oriented in the opposite direction, resulting in a net magnetization that is very small. And these substances are called ferrimagnetic material or ferrites. These are called ferrites. And these ferrites are generally represented by the chemical formula X O Fe2O3, where X stands for any elements: manganese, cobalt, nickel, copper, magnesium, zinc, cadmium, etc. Suppose if X is iron, Fe, then the compound will be Fe3O4, and it is the magnetite, which is the first magnetic material, the natural magnetic material. And in the case of ferrites, the magnetic moments in one direction are different from those oriented in the opposite direction and resulting in a net magnetization which is very small. And next is the spin alignment of different materials. As in the figure, you can see in the case of ferromagnetic material, the spins are aligned parallel in the magnetic domains. In ferromagnetic materials, the spins are aligned parallel in the magnetic domains. But in antiferromagnetic material, the spins are aligned antiparallel in magnetic domains. In antiferromagnetic material, the spins are aligned antiparallel in magnetic domains. In ferrimagnetic materials, the spins are aligned antiparallel but do not cancel. In ferrimagnetic, the spins are aligned antiparallel but there is a net magnetization which is very small. And in paramagnetic material, the spins are randomly oriented. And these are the spin alignment picture of different materials.